Your deploy pipeline can create its own monitor, post its own status page update, and silence the alert it's about to trigger without anyone remembering to do any of it. The UptimeRobot CLI is the official command line interface for UptimeRobot, and it turns monitoring into something you write once, commit, and run everywhere your code runs. In this video, I'm going to show you a few real jobs. First, we'll talk about status pages and maintenance windows through the CLI. Then we will do monitoring that ships with the deploy, and then bulk setup from a list. Before I continue with some practical examples, I will link here our video of how to use UptimeRobot CLI, which I recommend watching before continuing. Let's open our CLI. Status pages and maintenance windows. An announcement takes a title, some content, and a type, information, maintenance, or an issue. It goes to a status page ID rather than a monitor because it's page-level text. It appears above whatever checks that page is showing. There it is, published, a second after the comment returned. And you don't have to publish immediately. Set the status page to pending, give it a start and an end date, and it's scheduled, visible when the window opens, gone when it closes. Which means the message your customers read can be written calmly in advance as part of the same change that does the work, rather than typed under pressure while something is actively broken. The second job is quieter, and it's the one that saves your evening. A maintenance window needs 5 things: a name, an interval, once daily, weekly or monthly, a date, a start time, and a duration in minutes. Point it at the monitors it covers with a list of IDs, and those monitors stop alerting for that period. Planned work stops waking people up. That's the whole feature. One limit worth knowing before you rely on it: there is no way to close a window early. You commit to duration up front, so give it a little more room than you think you'll need. Monitoring that ships with a deploy. For this example, we are going to use a repository and GitHub. Here is the setup: one HTML file deployed to GitHub pages, and a workflow that runs on every post to main. The app is deliberately boring. The interesting part is what happens around the deploy. First, the key. In CI, you don't run the login command. You put your API key in your repository secrets under this exact name, and the CLI picks it up from the environment. Nothing is stored on the runner, and nothing is stored in the repo. It needs to be a main key rather than a read-only one, because creating things is a ride. The first job creates a monitor for the site that was just deployed: a name, the URL, a 60-second interval, and a 30-second timeout. There is one guard in front of it. Without it, every post would create another monitor with the same name, and you'd fill your account in a week. So it lists what's already there in plain text and skips the create if the name is present. Before committing any of this, run it once with --try--run. That compiles and validates the command locally. No API key, no network call, and prints exactly the request it would have sent. Push it and runs. The site is live and the monitor exists. Created by the same commit that shipped the code, reviewed the same way, and rolled back the same way. Now the part that makes this trustworthy. Here is the same pipeline with a read-only key in the secret. The deploy still succeeds, the monitor job fails, and the whole run goes red, because the CLI returns real exit codes rather than printing a message and exiting 0. There are distinct codes for invalid input, authentication, permissions, rate limiting, and a bulk job where some items went through and others failed. Your pipeline branches on the number instead of parsing text to the word error. 2 more things you get without asking. Credential-like fields print as redacted in every output format, with a note on standard error saying what was hidden, so your build logs stay clean by default and only reads as retried. A create that times out will never quietly leave you with two monitors. Then add the two commands from earlier in a job that runs first. This one opens a maintenance window covering the next 10 minutes, named for the commit that triggered it, and posts the status page announcement. And deploy waits for the job to finish, so the window is always open before anything ships. Prepare, deploy, then check. And now the deploy takes care of its own consequences. It announces itself, silences the alert it's about to cause, ships, and confirms the result, with nobody remembering to do any of it. The commit that caused the downtime is the same commit that explained it. One honest note on the dry run, because it's easy to overtrust, it validates the shape of a request, not the truth of it. Point it at a monitor that doesn't exist and it will pass. Then fail for real when it runs. It catches typos, not wrong answers. 6 services, 1 loop. Let's continue with bulk work, inheriting an account, migrating from another tool, onboarding a client who hands you a list of endpoints. Here is a short one, 6 services, name and URL. There is a separate create command for each monitor type, HTTP, keyword, ping, port, DNS, and a few more. So rather than looking up flags, ask the tool. Monitor SIM HTTP prints the required fields, the accepted values, the defaults, and the constraints straight from the API contract. Add das example and it hands you a complete request body instead. Save that to a file, edit it, and you can pass the whole thing back in with das body. Add the dry run and it validates locally. Then prints the exact request it would have sent. Nothing is created, which means you can check the shape of the entire batch before any of it is real. 6 requests, all well formed, still nothing in your account. Then take the flag off and let it run. 6 monitors, identical intervals, identical timeouts, identical naming convention, because the script wrote them, not a person on their 4th browser tab. Every command returns a real exit code, so the loop can tell you which rows landed and which didn't. That was about a minute. 30 would have been about the same, which is the point. The work stopped scaling with the length of the list. The command you'll reach for most isn't any of these, is does help. It works at every level and it prints the real fields and accepted values. This is the first step of UptimeRobot CLI, by the way. Automatic setup and deeper agent integration are on the way. And the install guide and how to start with the CLI video are linked below. Thanks for watching and happy monitoring.